Hello, Drew here with a video on Kirchhoff's current law, which is one of two of Kirchhoff's circuit laws. Kirchhoff's current law, or KCL as we call it colloquially, states that for any given node in a circuit, the currents flowing in must equal the currents flowing out. And in the notes, I state this as if you sum the current flowing away from a point, the sum must be zero. And the difference between these two is as follows. It's the same law, but all we do is we switch around what we name. So let's say we've got a current here, I1, and we've got a current here, call it I2, and then I3 over here. So at this point, this node, I1 plus I2 plus I3 must equal 0. All of these cannot be positive, right? If they were, this equation wouldn't work. One of them, at least one, has to be negative. And all that means is that we switch the direction that it's flowing in. So in this case, you can probably guess that I2 and I3 will be negative. We have a large current coming from the source, I1, that branches into I2 and I3. It could be that I2 and I1 are facing correctly, but I3 needs to be reversed and flows down that resistor rather than up. Regardless, if you set it up like this, just be consistent. Another way that we can look at this is if we just take our heads off here, switch the direction of these two currents, and if we change our equation here, get rid of our equal sign, and put it here. The current in, I1, must equal the current out, I2 and I3. It doesn't matter which side you put it on, as long as all the currents that you're saying are flowing out are on one side, and all the currents you have flowing in are on the other. Which is just like what we just did, where they're all on one side, right? All the currents we had flowing in, or I should say we had all the currents flowing in, and they were all on one side, they equaled 0. If you wanted to do it where all the currents were flowing away from that point, that's just fine. Just be consistent. So, given this, let's do an example. This is the example from your notes, and I encourage you not to look at the answers. I'll do a couple of them here in the video, and then have you solve the rest. And this is really good practice. This can be kind of confusing when you first start, although this one's a little easier to get a handle on, I think, than voltage law, since this is a bit more tangible. So to start with, looking at this circuit, I see two currents, unknown currents, that are really easy to guess. I6 and I7. And the reason for that is they are on the same branch as two known currents. So the 30 and the 24 here. Although the current flows out from a node here, it doesn't go anywhere. So we know that that 30 also must be I6, and the same for I7. So let's put them in reverse order over here. I7 is equal to 24 somethings, and I6 is equal to 30. Current can't go anywhere, so the current at the start of the conductor, or the wire, or the branch, must be the same as what it is at the end. Okay, so that gives us something to work with. Let's go to I1. At that junction, we have two arrows flowing out and one arrow flowing in. So we know we have current coming in on one side, or I should say we're saying that current is coming in on one side and it's coming out on two. So let's solve that one up. I1 is equal to 30 minus 10. Now all I've done is I've said that I1, which is flowing away, is equal to the 30, which is flowing in, so that's on the right side. But the negative 10, I've switched the direction, right? I've said instead of flowing in, it's flowing negative 10 out. Or sorry, instead of flowing out, it's flowing negative 10 in. So this would be my inside, this would be my outside. And it's negative because it's going in the wrong direction. And what do we get here? But 20. Okay, so we can delete I1 here. Let's put a 20 up there. Alright, where else do we know? How about I2? Alright, so I2, we have flowing out, so this will be my outside again. And we have 20 flowing in, so I'll put that on my inside. And since I want to solve this real quick without having to do a whole lot of writing, I'm going to say it's going to be negative 5 again. Even though it's flowing out, I'll put it on the wrong side, on the inside, and just flip the sign on it. And here we get 15. Alright, so now all we have left is I3 and I4. Solve those on your own and check your work with the lecture notes.